we noticed that many students experienced stress during our current course registration process, since external factors like luck and internet speed significantly influence their probability of getting into their desirable courses. As students, we deeply resonate with this stress, and we also recognize that the current system also adds much more pressure to the registration office due to the huge IT needs to support a stable registration environment. Inspired by Peking University's course registration system, we propose this new model that enrolls students based on their preference score. The higher the score they assign to a class, the more likely they will be able to enroll in that course. This system is specifically designed for registration staffs to assign courses for students. By using this system, we believe student satisfaction can be improved and the system's congestion will be avoided. There are three main inputs registration staff needs to upload to our model before running it. The first input is the sample data. Registration staffs need to send out survey asking students report their preference scores for the classes they would like to take and distribute the overall 100 points among all of these courses. This tab is specifically saved for the survey results. In our example, a student can choose up to 8 courses, including those backup courses, and distribute 100 points among all of these courses. Then, the registration staff needs to copy and paste the survey results to this tab. This is how it looks like after the data is imported. After importing data for this section, user can then click on the back button to back to the home page and proceed with the next step. The second step is to import the time slot table, which assigns each class slot with a unique number for easier scheduling. We will provide this data with our model, which now contains most of the slots for B-School classes, but the user can update this table if needed. After importing this data, user needs to click on the button to back to the home page. And then for the third step, the user needs to update the class information and fill out some relevant constraints. Registration staff needs to import all the classes open for students, which can be found on Course Atlas or within the school's internal system. And then they need to enter the maximum number of classes that they want our model to assign to every student. In our example, we use 3 to mimic the original first round of registration, which allows students to choose up to 8 credits of courses, which are approximately 3 courses. But the user can choose whatever number they think is reasonable. Also, the registration staff needs to enter the number of seats available for every course. Due to the limited sample size, we use divisor to scale down the numbers of seats available for each course. After updating all of this information, the user can click on the button to back to the home page. The data has been successfully uploaded and updated. User can then click on Run Model button to run the model. Our system will then automatically clean up all the data and then put the data into the model template and run the open solver to assign classes for students. After the model is successfully run, the user will get that information through a message box, and then they can choose whether to go to the next step. If they choose no, they're gonna stay at the model page to examine the model, but if yes, they're gonna back to the home page and can proceed to the next step. User can click on the final result button to retrieve the final result. The final schedule will then be extracted from the model and displayed in a clear and concise format as shown in the video. User can also choose whether to see the model or not. After having all of this result, registration staff also needs to connect with IT to upload that information to Opus. So that concludes how our model works. We believe that with this model, both student satisfaction and the platform's congestion will be improved significantly.